Okay, this is the last video of our trigonometry unit. This is a video on graphing sine and cosine functions. So what I really need to make sure that you understand, just so you can get a sense of why the graph looks like it does, which I'll show you here in a second, is what the different sine and cosine values are in standard position. So I've got a list of all the major angles on the unit circle, 0 to 360 degrees. And in this first column, that's all the different sine values. And in the second column, that's all the different y values. So the sine of 0 is 0. The sine of 30 degrees is a half. The sine of 60 is square root of 3 over 2. And the sine of 90 is 1. So you could see the sine value steadily increasing until they get to 90. And then at 90, they start to go back down towards 0. And then at 180, they continue to go down until they get to -1. And then they come back up to 0. So you get a little bit of a wave as these sine values go up and down, up and down, up and down, up and down. So the sine graph models these y values going up until they get to 1, and then going down until they get to -1, and then going back up and then going back down, staying the whole time between 1 and -1. And our cosine, the cosine of 0 is 1. So the y values are up at 1, and then they start to decrease and they go down to -1, and then they come back. So it's also a wave situation. So let me just show you the parent function for both of these real quick. I got them drawn out for you here. All right, and again, as always, pause your screen, sketch onto your notes if you got these from your teacher, or if you don't have these, take a moment and sketch your own graph. What I've got here is an x and a y axis. My x-axis are all degree measures, whether they're in degrees, so they're angle measures. Angles on degrees and in radians there, you can see that in red. And then my y values are all the y values that represent my sine values. And so that's up to 1 and down to -1. You could see that. And you got 1/2 square root of 3 over 2, and then 1, just modeling how they're going up and coming down. And again, this wave, this is just what we call one period or one lap around the unit circle. We started at 0, went up to 1, kept going down all the way to -1, and then starts to work my way back up. So it's like peaks and valleys, peaks and valleys. And this is continuous. This is just between 0 and 360. I can have negative angles, and that's going to keep waving out to my left. I can have angles bigger than 360, and that's going to keep waving out to my right. So it keeps going, but what you need to make sure you understand is at 0, the sine value is 0. The maximums are 1, the minimums are -1. Something called amplitude, which is basically how far the wave gets from the x-axis. That is representing the vertical stretch that you might experience depending on the equation that you get. We talked about a period, and what we have in our graph is how much of this wave do you see, and the portion of the wave that you see is for one full circle or one full revolution. The domain, I could put any x values in here. I could keep going negative infinity all the way up to positive infinity, but my range stays between, so my y value stay between -1 and 1. All right, so that's the sine graph. All right, the cosine graph, notice this time it starts up at 1, works its way all the way down to -1, and then comes back up. So cosine, different from sine, starts up at 1 and then works its way down. But over time, these two graphs look very, very, very similar to each other. They have that wave. They stay between 1 and -1. And that's what we've got going there. The maximum, again, 1, minimum -1. The amplitude is 1 because that's the distance from the x value. The period in this case is just over 1 full revolution, 0 and 360 or 2 pi. The domain was any x values. There are no restrictions on the x values. It keeps going and going and going and going. I just have a small section of it here, and then the range is from -1 to 1. All right, so that's your two parent functions for sine and cosine. Again, they come from the values and what these sine and cosine does for each of these angles. So again, sine starts at 0, works its way up toward +1, and then starts to come back down till it gets to -1, and then it works its way back up. Cosine is up at 1, and then it goes down to -1 and back up to 1, and down to -1 and back up to 1. So again, over time they look very similar, but the subtle differences with at 0 what's sine doing, and at 0 what's cosine doing. All right, a couple of vocabulary things for you. All right, so the midline, that's, in this case, it's acting like the x value, but the midline is exactly what it says it is. It's that line, that horizontal line that you can draw right down the middle of the curve, and it's equally above as it is below. So the midline is that horizontal line through the middle of the function. It's the average of your x and your y and your minimum and maximum. All right, so typically tells you, it's a horizontal line, so it's y equals a number, and we can get that from what's called the a value. So if you look down here at this example of something a little more complicated than just your basic sine function, this value a right here, that's what's going to start telling you some information, b, c, and d. That midline typically is going to be D right there, because it'll tell you how far up or down you need to translate to get to. That's going to be your midline, because the parent functions for both sine and cosine. The midline's at 0 or the x-axis. So if it tells you to translate down, you'll go down, and that takes the midline down. If it tells you to translate up, then you'll go up, and that takes the midline up. So that D value is going to tell you what your midline is. All right, and that's going to be your vertical translation. All right. The amplitude is how high and how low the function reaches. We talked about that up here. So the maximum and the minimum, how far above and below the function is going above the midline. So that's your A value. That's your vertical stretch. Your A value is your vertical stretch. So in this example that I gave you, 3 is your amplitude, which means it's going to go up to 3 and down to -3. Above 3 units above the midline, 3 units down, 3 units below the midline. So not necessarily +3 and -3, but 3 units above whatever the midline is, 3 units below whatever the midline is. Then there's the period. That's B. Now it's a little bit more complicated than just what B is. B, it's 2 pi over B. But what the period is it tells you how much of the sine wave or the cosine wave that you're looking at. So a period is the section or the quantity of the wave that you're going to see. So if you're only going to see it for a period of pi over 2, that's about a 90-degree section of the graph. So a quarter circle is about how much of the period that this graph would be showing. I can make it bigger, I can make it smaller, I can stretch it out, I can jam it together, but the period tells you how much of the wave that you're looking at. Okay, and then we have this idea of a phase shift, and that's just your horizontal translation. So if I want to scoot it to the left or scoot it to the right, that comes from this phase shift, and that's the C value. So A, B, C, and D, those values are important to help you understand the behavior of this line, behavior of this wave, because they're unique, and without that information, it all just kind of looks the same. So just as more of a reference, if I gave you this example here, this is the behavior that a normal function would be having. And so those same reflections and stretches and translations are similar to that of a sine or a cosine function. It's just got the word sine in it as opposed to an x squared or a square root. So it's all the same translations. We're just using a few different vocabulary terms. Remember that midline had to do with your vertical translation. Amplitude had to do with your vertical stretch. Period was part of the horizontal stretch. And then phase shift was your horizontal translation. Okay, so all that information. And as always, feel free to pause your screen and get that information down on your paper if you don't already have it. So I want to do one example with you, just kind of put it all together here. All right, so I'm going to do this example right here with you, and we're going to graph this, and you should be good to go after this. Okay, so I've got, and I don't know why I don't have a y value here, so y equals, okay, y equals -2 times -2 sine of x minus 4. All right, so this negative is going to tell me to reflect. So the sine function starts at 0 and then goes up. So this time, instead of starting and going up, I'm going to end up doing something that looks more like that. So that's what that reflection is going to do for me. The next piece is it looks like I'm translating down 4 units. So that means my midline, or the middle of my wave, is going to be at -4 now. Okay, so I've got a midline here at y equals -4. Remember, that's the middle of my wave. Now, the amplitude, that's what this 2 is, that vertical stretch. So that means that I'm going to be 2 units above the midline and 2 units below the midline. So I'm still going to have a sine wave. I'm still going to start at 0, and I'm going to start decreasing and then increasing because of the reflection. But I'm only going to go down 2 units and up 2 units. All right, so notice that I've also got this thing labeled. What is 2 units above -4? Well, that's -2. And what's 2 units below -4? That's -6. All right, so let's see if we can put all this together now. Remember that I'm only going to do this over one period, only one lap around the circle, so that's 0 to 360, or 0 to 2 pi if you're doing it in radians. So I'm going to go, in this case, because I reflected, I'm going down first, and then I'm going to come back up to -2, and then back. I missed my point here. Oh my goodness. I'm having some issues here. I'm going to try this one more time here. All right, there we go. Now we got it going. Okay, so again, we reflected down, so that's why I went down from the sine first. And then we went down 2 units below, and then we changed directions at pi over 2, or 90 degrees, and we start to work our way back up till we get to 2 units above, and then we work our way back down. And it just continues the wave. So this is not the entire sine wave. It's just one period, or two, or one, not one period, but one lap around the circle. Okay, so that's how I would graph that with all that information. Remember to look at your A, B, C, and D value to figure out the information about your waves. I hope this was helpful. Good luck. Thank you for listening.